This is Mr. Beck Does Your Homework, AP Physics, Homework 5.1, questions 10 and 11. Question 10, a bead slides without friction around a loop-the-loop. Zoom. The bead is released from a height 20.3 meters from the bottom of the loop-the-loop, which has a radius of 7 meters. What is the speed at point A? Answer in units of meters per second. Well, I'm going to ask myself my questions. Up here, is it moving? No, it's not moving. So I know that my KE at that point is going to be 0. Up here, can it fall? Sure can. It can fall 20.3 meters. So it's got some PE. Well, that total amount of energy there is going to be the same as the total amount of energy here. So here, is it moving? Well, sure it is. It's moving around that loop, so it's going to have some KE. It even asks for the speed, so I know it's moving. And can it fall? Yes, it can. It can fall from here all the way down to what I say is 0 down here. So it's got some PE there. So what I know is I've got some m times g times my initial height, so I'll call that h0, equals my kinetic energy, 1/2 m times v, we'll call that velocity at a squared, plus my mg times my height at a. Now if I'm going to be solving for velocity, I'm going to want to bring this over and subtract it. So I'm going to go get mg height of 0 minus mg height at a equals 1/2 m times v squared. Now two things are interesting here. One thing is that the mass cancels out, so I don't care about it. They don't give it to you later anyway, but my mass cancels out, so I don't care about that. But here I could factor out a g because I've got g times height 0 minus g times height a. So what I could say is that g times height 0 minus height a equals 1/2 v squared. What's neat about that is that it's the change in height that matters. So over here, if I think about this as, if I just said that this height was 0, what I'm really interested in is this difference in height right here. That's my change in height. It's going to be 20.3 minus something over here. What's this height? Oh, this is 7 meters, so this must be 14 meters for me. Twice the radius is my diameter. But if I did 20.3 minus 14, what I'm left with is just this change in height, because that's how much potential energy it loses. It loses more, but then it gains it back. So overall, the difference between here and here is a loss of potential energy of only that much. So this is my change in potential energy, if I have the mass in there, is going to be my change in kinetic energy. So I started from rest, so I'm gaining this much kinetic energy. So for me, this is going to be 9.8 times my change in height is going to be 20.3 minus 14 equals 1/2 of v squared, and I can easily solve for my v. How large is the normal force on it at point A if the mass is 3 grams, answer in units of newtons? This is a circular motion question, but now I have a velocity. So what I have here is at the top of the loop, I've got a normal force in this direction. I've got a gravity in this direction, and they're both pointing in the same direction. So I know that my normal force plus my gravity is going to equal my centripetal force. If I subtract gravity from both sides, I will be able to solve for my normal, which is going to be my centripetal minus my gravity. So my normal force is going to be mv squared over r minus mg. Now, what is m? Well, for me, it said the mass is 3 grams. Well, I can't plug in 3 grams. What I have to do is take 3 grams and convert it into kilograms, and I know that 3 grams is going to be 0.003 kilograms. So that's going to be my mass. So my mass is going to be 0.003 kilograms, and that'll go in there, and also in there. G is 9.8. V is going to be this velocity here, and my radius is going to be 7 meters. So now I can get myself a normal force when I plug in all those numbers.